Solving equations. Solve two-step equations. When solving two-step equations, we use the reverse order of operations. So the normal order of operations is PEMDAS. So you can see here, PEMDAS. But we use the reverse order of operations, SADMAP. And we need to think a little bit about what that means. With the order of operations and the reverse order of operations, we do subtraction and addition at the same time. That's why I put this curly bracket there. At the same time from left to right. So we look in the equation from left to right, and whenever we find a subtraction or addition, we do that. After all the subtraction and addition are done, we do division and multiplication again at the same time, hence the curly brackets from left to right. And my arrow on these says from left to right. So if we come across a multiplication before a division, we do that first. If we come across a division before a multiplication, we do that first. Once all the subtraction and addition are done, and then all the division and multiplication are done, then we do exponents. And finally, we do whatever is inside parentheses. SADMAP. So that's what we're going to use when we are solving these two-step equations, which we will check the solutions for. All right, so SADMAP. Are there any subtraction or addition over here? Remember, our goal is to isolate the unknown value x. Here is an addition. So the inverse operation of addition is subtraction. So this makes it 0. So we have 2x on the left is equal to 13 minus 5 is 8. Our next step, well, we have 2 times x. The inverse operation of multiplication is division. So we divide by 2. And that gets our x by itself. 8 divided by 2 is 4. So now we plug our 4 into the original equation to check our solution. So I'm going to put a little dotted line here saying this is our check. So we have 2, and then I'm doing multiplication up here in the original equation. So make sure that I do multiplication in the check as well. Plus 5 is equal to 13. So we've taken this original equation, we've rewritten it with x is equal to 4, substituting that in. Now, when we're checking, we use PEMDAS. So is there anything to do inside the parentheses? No. Are there any exponents? No. So now we do multiplication and division from left to right. So as we look through our equation here, we have multiplication right here. 2 times 4 is 8. Now we have plus 5 is equal to 13. 8 plus 5, that is 13, equals 13, and it checks. So we've checked that solution, we solved, and then we checked. So there's our answer there. All right. On this one, we're doing our work over here on the right. So because that's where we're going to isolate our x value, that's where it is. So are there any subtraction or addition? Yes, we have subtract 11 here. The inverse operation of subtraction is addition, so we add 11 to both sides of the equal sign. Negative 17 plus 11, well, that's kind of tough. It is a negative 6 is equal to negative 3x, and remember this makes a 0 right here. So now we have a negative 3 times x, so we have to do the inverse operation of multiplication, which is division. So we divide by negative 3. Make sure it's a negative 3 there. Lots of students lose this negative in the division. It's also important to remember that a negative number divided by a negative number is positive. So the result there is 2 is equal to x. And now we can check that, and we're going to plug our solution 2 into the original equation. So we have negative 17 is equal to negative 3 times 2 minus 11. So now we do PEMDAS because we're not solving now, we're just simplifying one side. Negative 3 times 2, well, that's negative 6 minus 11. On the left-hand side, we have that negative 17 just comes down. And on the right-hand side, negative 6 minus 11, that is negative 17. And that checks. All right. So we're solving, we're undoing operations to isolate our unknown value x. So here we are actually adding an 8. This subtraction might throw you off and make you think we're subtracting 8, but this is a positive 8. And if we think about if we moved it over here, it would just be plus 8. So we can see we're adding 8 there. So the inverse operation of addition is subtraction. 14 minus 8 is 6. And then we have negative 2/3 x. And this subtraction becomes that negative right there. Now we have negative 2/3 times x. So to undo the operation there, we're going to actually multiply all of this by the reciprocal of the fraction 2/3. That really is the same as dividing by the original fraction. So we multiply by negative 3/2 on both sides. And I don't need to put parentheses here. I could, but whenever there's a number in front of parentheses, it's definitely multiplication. So this is like 6/1. This negative times a positive is going to be a negative. So it's going to be a negative. And then 3 times 6 is 18/2 is equal to x. Now here, we need to simplify that negative 18/2. It's negative 9 because remember that's division. So now we can check that solution. So we plug negative 9 into our original equation. So we have 14 is equal to 8 minus 2/3 times negative 9. And right here, we have multiplication. Negative 2/3 times negative 9/1, that's going to be a positive 18/3, which is 6. So this is going to be 14 is equal to 8. And because it was a negative times a negative, it's a positive 6. And now 8 plus 6 is 14, and it checks. Lastly, SADMAP, subtraction addition. Here we're adding 4. So the first thing we do is we subtract 4 on both sides. We have x/3 is equal to negative 5. Now all we have left is dividing by 3. The inverse operation of division is multiplication. So we multiply by 3. And on the left, we have x is equal to negative 5 times 3 is negative 15. So we're going to plug that negative 15 into the original equation. So we have negative 15/3 plus 4 is equal to negative 1. Well, negative 15 divided by 3 is negative 5. So we have negative 5 plus 4 is equal to negative 1. Negative 5 plus 4 is negative 1 equals negative 1, and that checks. And those are 4 examples of solving two-step equations.